Okay, so we have several methods of solving problems like these, but I think the easiest method from my little experience is long division. Yeah, you can convert the numbers to base 10 and then you divide and then you convert the numbers back to base 2. That's okay too, except that uh, in most cases, students who do that tend to forget to convert the numbers back to base 2. So I'll use long division here, except for one which is too easy. So let's get started. Evaluate this number giving your answer in base 2. So there is this method which one of my students, Chimwemwe, taught me. So it's basically long division, but for those who have challenges forgetting the order of operations, this is something one of my students came up with. Dead monkeys smell bad. So this is division. So after you divide, you have multiplication, and then after multiplication, you have subtraction, and then after subtraction, you can bring some number down, the next digit down. So now let's divide. So you can say 111 into 1. This is not possible, so you involve the next digit. So you can say 11 into 11. This is a 1. And then after division, you have multiplication. So on the part of multiplication, you multiply the number you have just derived, or the quotient, the new quotient, by the number you are dividing by. So you can say 1 multiplied by this is an 11. And then after multiplication, you have subtraction. So you can subtract this minus this, you have a 0. This minus this, you have another 0, but it's pointless to write two zeros like this. So let's just leave it like so. And then after subtraction, you can bring the next digit down. So this is bring down as they call it. So you can put a 1 there, and then 11 into 01 or 11 into 1. This is not possible, so you can just put a 0 on top of the one you have just brought down. Yeah. So now after dividing, remember we have restarted the process. So after dividing this by this, we have a 0. The next operation is multiplication. So you can say this multiplied by that, you have a 0. And then after multiplication, you can move on to subtraction. So 1 minus 0, you have a 1. And then after subtraction, you can bring this number down. You have an 11. And then after bringing the number down, you restart the process. So you can say 11 into 11, this is a 1. And then now you multiply the digit you have just, the quotient here, which is a 1, multiplied by 11. So you can say 1 multiplied by 11, that's 11. Then you can subtract the two digits and you have a 0. Since you do not have any other number to bring down, you can consider the problem solved. So let's proceed to the next example. So divide, we have 11 being divided, I mean we have 1 0 0 1 0 being divided by 11. So now remember, when you're dealing with numbers in base 2, you only have two digits. You have zeros and ones, and don't forget the order. It's division followed by multiplication, and then subtraction, and then bring down as my students call it. So you can say 11 into 1. This is not possible, so you involve the 0 there. 11 into 10, still not possible, and then you involve the other 0. So now remember, in base 2 you only have zeros and ones, so you can say 11 into 100. If division is possible, then your answer is always yes or 1. If not, then your answer is 0. So since 11 can go into 100, we can conclude that it goes into 100 one time. So you write your 1 there. And then after division, you move on to multiplication. So 1 multiplied by 11, your answer is 11. But you will not write your 11 here. You write your 11 just below the 100, because you're now subtracting an 11 from 100. This is not really 100 per se, but let's call it that. And then at this point, now that you have multiplied, you can proceed to subtraction. So we can say 0 minus 1. This is not possible. So what do? You borrow from the next digit, but we have a 0 here. So you borrow from the next digit again. So now you borrow a 1 from there, but because we are not in base 10, we are in base 2. When the 1 comes here, it will manifest itself as a 2, if I may use that language. Because in base 2, you are dealing with 1s, 2s, and then 2 squared, and then 2 cubed, and so on. So the moment you bring this guy here, it means it's a 2 now, it's no longer a 1. So from these 2, we can borrow a 1, we remain with a 1, and then once we borrow a 1 from there, we will not write it here as a 1 so that we have a 10. It will be a 2 like this. And by the way, you are not making it a 20 like we do in base 10. Because in base 10, you are bringing a 10. So when you add it to this, let me not explain that, I may confuse you. I can do that in a separate tutorial. So now we can say 2 minus 1. Yeah, this is doable. We have a 1. And then 1 minus 1, that's a 0. So no need to write the 1 down. And then after subtraction, we can bring the next digit down like this. And then we can say 11 into 11. This is a 1. And then after division, remember we have restarted the process. After division, we can move on to multiplication. So this multiplied by this, that's an 11. And then after multiplication, we can subtract. So this minus this, that's a 0. Then after subtraction, since we still have a digit here, you can bring this digit down. And then 11 into 0, that's a 0. And then this multiplied by this, you have a 0. And then now we can subtract again so that we have a 0. Since we do not have any number to bring down, we can end here. And then next one. So the next problem is 2024. This was paper 2. So we can say this, evaluate this divided by this. So to divide, let's use long division still. So you can say 101 divided by 1, 1001. 101 into 1, this is not possible. So you include this. 101 into 11, still not possible. 101 into 110, this is possible. Remember, if it's possible, then you have a 1. If it's not, then you have a 0. Because in base 2, we only have zeros and ones. So you can say this into this. Since this is possible, you write your 1. So make sure that you write your 1 on top of the 0 here, the last digit you're dividing by. Yeah, and then the order of operation is division followed by multiplication, subtraction, and then bringing some digit down. So now that we have divided, we can proceed to multiplication. So this multiplied by this, we have 1, 0, 1. And then now we can subtract. So this minus this, it can't. And because we're in base 2, because subtraction is not possible, we can borrow a 1 from here. And then because we're in base 2, it will be that one we have borrowed from here will be a 2 there. Yeah, so now 2 minus 1 is 1, and then we have remained with a 0 there. 0 minus 0 is 0, 1 minus 1 is 0. So now at this point, after subtraction, we can proceed to bring the 0 down, and then after bringing the 0 down, you restart. So 101 into 10, not possible. So if your answer is no, then you have a 0. And then after division, you can multiply. So now we are multiplying 0 by 101. We're not multiplying by 10, it's this 0. So 0 multiplied by 101, we have 101. And then I think I missed something. Oh yeah, after bringing this one down, we needed to divide. Sorry, this into this, we had the 0, and then this times that. Sorry, I forgot one step. I forgot to multiply this by that. So we have a 0. And then now we can subtract these two. It's solvable like this, but I don't want to confuse you. I just want to use standard methods. So 0 minus 0, you have a 0. 1 minus nothing, you have a 1. And then now after subtracting, you can bring this one down since we still have a digit. So 101 into 101, we have a 1. And then we can multiply 1 by this. Remember, after division, we have multiplication. So this times this, we have 101. And then now we can just subtract these two, we have a 0. Since you do not have anything to bring down, you are done. And then we can proceed to the next problem. By the way, if you get any number there, it may mean there is something wrong with your work, or the question has a remainder. But in most cases, at ECZ level, they'll give you numbers which do not have any remainder. So if you are seeing any number at the end, just go through your work. It may be a very small mistake. The next problem is find the value of this. So we have this is 2024 external 111100011. Okay, so remember, yes means 1, no means 0, and then the order of operations is division, multiplication, subtraction, and then bringing down. Dead monkeys smell bad, if I may. So you can say this into 1, that's 0 because it can't. And then this into 10, you include the 0, it still can't. So we don't put zeros in front of numbers. So this into 100, this is still not doable. So now you include the third 0. And then you can say 111 into this number here. So this is 1 because this is doable. As you can see, this is bigger than this. So if division is possible, once again, the answer is yes. If not, the answer is no, which is a 0. So now after dividing, you can proceed to multiplication. So 1 multiplied by 111, you can say 1, 1, 1. Please ensure that when you're writing this 111, you start from this 0 here. So you can say 1 here, 1 there, 1 there. Do not write it here, because you are subtracting this from this number, this entire number. And then after this, you can subtract. So 0 minus 1, this is not possible. So you borrow a 1 from there, but it's not possible because this guy has nothing. You ask the next guy, still nothing. So you borrow from this leading one here. So now you have a 2. Remember, when you're in base 2 and you borrow a 1 from this number, it becomes a 2 there. And then from this 2, we can borrow a 1. So we have a 2 there. But this guy still needs a 1. So we can borrow a 1 from there. And then you remain with a 1 there. And then you have a 1. So 1 minus 1, you have a 0. And then 1 minus 1, you have another 0. And then 1 minus 1, actually this is a 2, my bad. Because after borrowing a 1 from here, you have a 2. So 2 minus 1, you have a 1. And then 1 minus 1, you have a 0. 1 minus 1, you have a 0. So now, at this point, now that we have subtracted, you bring the next digit down, this one here. So now 111 into 11, this is not possible, so you write a 0. And then after division, you multiply. So you can say 0 multiplied by 111, that's a 0. You subtract, you have a 1 and a 1. And then after subtraction, you bring the next digit down like this. And then 111 into 111, that's a 1. And then 1 multiplied by 111, you have 111. Then you can subtract again so that you have a 0. And because you do not have any number to bring down, you are done. So this is the answer here. Lastly, we have this one. This is too easy. I may have seen something like this in 2015, if not 16. So to divide these two, you may not even need to go through long division or converting to base 2, to base 10, and then dividing, converting back to base 2. This is straightforward. Maybe for the sake of markers, because you don't know who will be marking your paper. But to divide these two numbers, you can just use this ordinary method. The rules for cancellation of zeros is still applicable here. So you can just cancel out this 0 with this 0, cancel out this 0 with that 0, and your answer is 101 base 2. If you're not comfortable with this, I would equally be worried about my marker. So you can just proceed and use long division or any other method that may give you some, I don't know if I should say confidence, or maybe surety. So now you can attempt these 5 problems in your own time.